Okay, so here's one of my favorite questions in this section. So a business problem, and also involving quite a bit of visualization and some geometry. So a cable vision company is laying cable in an area with underground utilities. We've got two subdivisions. They're located on opposite sides of a creek. The creek is 100 meters wide. So the company has to connect point P, the new subdivision, and Q with cable. Q is on the north and it's 1,200 meters east of point P. And here are the restrictions, the constraints that we have to work with. It costs $40 a meter to lay the cable underground and $80 a meter to lay the cable underwater. What's the least expensive way to put that cable down? Okay, so you can see there's lots of ways to do this. We could say, I'm just going to connect points P and Q in a straight line, but then all of your cable is being laid. It's the shortest distance, but it's the most expensive method. The other option is to go straight across so that you're using the least amount of expensive cable and then straight this way. But that's the most amount of cable that you could possibly use. So you're going the shortest distance or the longest distance, probably somewhere in between. Okay, so think about what it is you're trying to minimize. We're trying to minimize the cost. Can you write an equation for the total cost? So let's do this in steps. The total cost is going to be the cost for laying that underwater plus the cost for laying that underground. And how do I know how much it costs to lay that underwater? So I'm just going to use C with a subscript T to represent the total. Well, I would take how much I have to pay per meter to lay this underwater, $80 a meter to lay this underwater, 80, and I'm going to put units in here just to get this correct, $80 per meter times the distance, the number of meters. And then our meters are going to cancel, and we're going to end up with dollars. Plus the cost to lay this underground, $40 per meter, times the distance that I put it underground. Okay, so then let's come up with some kind of variables here. That is, if I look at this distance, I'm going to draw this right angle triangle, and I'm going to call this distance here x. Oh, sorry. I'm assuming here that this point is somewhere in between. So I'm going to connect this like that and call this point here X. Okay, so cable comes across the water and lands on the other side at some point X. Then the distance that I have to lay this cable underground would be 1,200 minus X. Okay, so the distance that we lay the cable underground would equal, so I'm just going to call that D sub G underground. I'm going to label that as 1,200 minus X. And then the distance that I lay this cable underwater, this would be the distance I lay that cable underwater. Then tell me what that distance is. Can you come up with an equation for that? We've got a squared plus b squared equals c squared. It's Pythagoras. So this distance here would be the square root of a squared plus b squared. What's this distance here? x. Okay, so let's give ourselves a key, because we really have only one variable here, and I think it's important that we clearly define what that variable is. So we're going to let x equal the horizontal distance from, I'm going to call this point here R, directly across the bank, from R to where the cable lands on the opposite shore, R to cable landing. I need more vocab, but there we go. Okay, so then let's rework our cost equation. 80 times the distance in meters that this is laid under water, and that would be the square root of 100 squared plus x squared plus $40 a meter times the number of meters that we lay this underground, and that would be 1,200 minus x. Okay, and that's going to give us cost in dollars. Okay, now let's not lose perspective. What we're trying to do, we're trying to find the least expensive way, minimize the cost. Okay, so this is the function that we are trying to minimize. How do we do that? Take the derivative and find the critical numbers. So what is c prime at t? So go ahead and take that derivative.